Let's dive in to another video which involves reaction of aldehyde and the ketones. So this reaction is hydration, which also involves hydrazine formation. So as usual, let us first see the requirements. So here the requirements, the first requirement that you need is water, which is H2O. Number 2, you can use an acid here, which is H3O plus. What else? Number 3, a starting material. You can get an aldehyde or a ketone, or we say a carbonyl compound here. Like aldehyde or ketone. Okay, let's go to examples. Allow me to get a ketone, an aldehyde, like this one. Then we have H2O, number 2, we have an acid. What will be our product? So now our product here will be a geminodiol, which means 2 OH will be added on the same carbon, So here our answer will be like this: OH. That's our geminodiol. We can regenerate our acid. Example number 1. Example 2. Let's get a ketone. Let's use a 3 plus in water. Meaning we produce the same product, but provided here now our answer will be still a geminodiol. And this is what we call hydration. Example number 3. Okay, what if we use water in acidic? So simply add 2 OH group on the function group of a ketone, like this. That's our answer. Another example, some professors will just give you a ketone or an aldehyde, and they just indicate water here. What will be your product? So don't get confused. The product will be the same, because water can go auto ionization to form a base and an acid. So the product will be the same. So auto ionization, what is it? So it means water can react with itself to form hydronium ion or oxonium ion, which is an acid, plus OH. So there's a ability of forming an acid and a base. That's what we call auto ionization. So what are the key important things that we have observed in all these reactions? The second one is that there is formation of geminodiol. Meaning two OH group are connected on the same carbon. Acid can be degenerated. So these are the three things that we have noted in this reaction. Let's now go to the mechanism. So now we are on the reaction. Mechanism. So for example, if you have this your ketone, you're reacting with the acid and water. So we are saying that our product will be OH and the OH, geminodiol, on the same side. So how can we move from point A to point B? So the first thing that you have to do is you get your starting material here, you indicate your lone pairs. Then your acid, one lone pair with a positive charge. So meaning the oxygen will use its lone pair, grabbing the hydrogen, expelling the bond. Meaning your product is something like this. I have two bonds there connected to a hydrogen with one lone pair, and automatically it becomes what? Positive. Plus what? Plus water. The water that has been generated here. From this point, we can get another water molecule, this one, this, of which the same one, which is here. This water worked as a nucleophile, attacking there, expelling this bond. So from here, meaning we're going to have something like this. Oxygen connected to hydrogen with two lone pairs, and our water being added. There now, the water which has been added is not stable. It can leave. So to avoid that, we're going to get the water molecule that we formed at the initial here to protonate it. So we are going to use this lone pair, attacking the water, the hydrogen, expelling this bond. So which means from here we have this compound plus what? Plus our acid. So the acid has been regenerated. So here we put our acid back, which has been regenerated. So acid acts as a catalyst. It is never used in the reaction, but it is being regenerated. So this is the reaction mechanism for hydration. Thank you for watching. Stay tuned for more.